All right, so let's get into today's session now. So, based on what you should have completed by now, you should know how to create basic APIs with the full suite of CRUD operations. CRUD meaning create, retrieve, update, and delete. You would have submitted two things already. I think I want to use part of today's session to start looking at those and start grading them. But we'll see how things go as we proceed. So that's stage one. And you would have been working with things like lists and dictionaries. And the challenge with those kind of data structures or repositories is that they are actually stored inside of main memory. Therefore, whenever you exit, you will lose all of that data. And so each time you re-execute your API, you're pretty much starting from scratch. So there must be a way in which we can persist the data. And when we talk about data persistence, we're really talking about just storing the data for long periods of time. And that's where our databases come into the picture. And what we want to try and do is to look at two types of databases, one being a structured database and the other one being a non-structured database. So in terms of the structured, we'll be looking at PostgreSQL. And when we say structured, we're really talking about tabular data. And you would have been exposed to this when you did database management. So structured data, we have to create our repositories. And when we create our repositories, we have to ensure that we set up the structured data. So we have to indicate what is the table name, what are the fields, what are the data type for each of the fields, and use that to flesh out what the structure of the table is going to be. The challenge with that is that if we want to store data that varies in any shape or form, then we run into some database anomalies. Well, potentially, or well, the word is not inconsistencies, but when I find the right word, I'll just mention it. But let me give you an example. So if I'm going to, well, inefficiencies, that is the word. If I'm going to store first name, last name, and hobbies, and I have two slots for hobbies or two fields for hobbies, and the person does three hobbies, then I'm going to have a challenge in terms of how do I represent that? And one way in which I can think about doing it is to create another record for the person. But if I do that, then that is bad because I would only be able to store one additional hobby and one of those spaces would be left empty. So we would be wasting space. Additionally, we would now be storing two records just to show the fact that a particular person has three hobbies. So that's a potential challenge in terms of how efficient that would be. Now, if it is that we say that we are going to create the number of fields to match the maximum amount of hobbies which are possible, we can store up to a hobby vacant. And once again, we're going to run into space constraints or considerations. So because of the rigid structure of tables, then idea that we can save data, but we don't have to save it in that rigid format. And so they come up with the databases, for example, MongoDB. And when you look at MongoDB, one of the key things that you will find is that you're starting to store data in terms of JSON objects. Now, this shouldn't be anything new to you because you have been working with Python dictionaries. And Python dictionaries, as you know, is made up of key value pairs. So there's a key, there's a value. And we separate the key and the value by using colons. Well, that's exactly how JSON data actually looks. It is made up of key value pairs. So once you have worked with dictionaries, then you pretty much have been working with JSON-like structures. Now we have an example here of how it actually looks. And this is just a reminder for you because you would have, kind of been exposed to dictionaries. So in this case, we have several fields or several keys. So we have a field for image, one for first name, last name, and I think you get the picture. And beside those keys are the data values. So for example, first name is Cheryl, last name is Carter. And you would also realize that we separate each key value pair by making use of a comma. So that's pretty much JSON data. And what we want to look at throughout this week is how do we configure or set up our databases, meaning PostgreSQL and MongoDB, how do we set them up? And also, how do we interact with them in terms of adding data? All right, so that's pretty much what the aim is or the consideration is for this week. Now, once we get that out of the way, then what you would now do is to update your APIs so that now instead of just storing the data and it's lost whenever it's shut down, you can now push that data into your repositories. So you're going to store them or persist the data. And so if you need to retrieve at some then that data is not lost because it is in its repositories. Any question? All right, so no questions, mean that everything is understood so far. Now, I'll be asking you to do a couple of things because traditionally I would have said to you, just go and locate the installation files for both databases and install them directly on your machine and then we'd find some sort of GUI that we would use to talk to them. I think I want to kind of hold it simply because things have become I just surveyed it that people talking a lot about containers and virtual machines and technologies and CI/CD um, and my mic keeps chipping out.
Yes,
Right.
sir.
Maybe it's the Wi-Fi. Let me try something. Give me a sec. All right. Am I sounding any clearer? All right. If it starts chip again, let me know. All right. So let's go back over what we were talking about. So we're talking about the fact that we want to ensure that we have some way of persisting the data when we create our APIs. So far, what we have been doing is we have created the APIs, but the data was actually stored in RAM, main memory. And what this means is that whenever we shut down or we terminate, then all of the data that we would have stored is actually lost. So we want to persist the data, which means we want to store the data over long periods of time so that we can retrieve stuff that we have done before. And that is why we want to look at databases and what they bring to the table. Now, there are two types of databases that we have. We have structured databases and we have non-structured databases. And when we talk about a structured database, we're talking about one in which we define the structure of the repository so that all the records that we are going to store, they have the same look and feel, they have the same shape. So that brings us to the whole concept of tabular data. And this is something that you would have experienced or interacted with whenever you did database management, predominantly. We also have another type though, and this is a bit more flexible in kind of how we store the data. Now you'd have also touched, but it might not have been, a whole lot. Suffice it to say that when we talk about non-structured, the tool that we are going to be using is MongoDB. And MongoDB stores data in JSON format. And I'm saying that you should be familiar with JSON format because you would have been using or you would have made use of dictionaries in Python. And when you dictionaries, the key thing here is that we end up with what is known as key value pairs. So there's a key and there's a value. So for example, we have a key called first name and we have a value called Cheryl. So those two pieces of data are tied together. There's a comma as you look through the listing here. There's a comma that separates each of these key value pairs from each other. So that's how we will be storing our data in MongoDB. The other thing that I was mentioning earlier is why we came up with something like a MongoDB. And I'm saying that the challenges we have with structured databases is that it does not give us a whole lot of flexibility whenever there are missing fields. And this can lead to a whole lot of inefficiencies, such as wasting space. We don't want to waste space. We want to be as efficient as possible. So in a case, for example, where we're storing the names of persons and the hobbies that they do, and we say that we create a table, and in the table we have 10 different fields to store hobbies. Now, I know you know by now that that is a bad way to do it based on database design. But just for argument's sake, we are saying that there are 10 fields which have been allocated for hobbies. because that's the maximum that they can have, 10 hobbies. Then you will find that if a person only does one hobby, then it means that we're wasting space for 9 of those fields. And those wasted space add up over time. And the reason why those spaces are wasted is because there's no way within the structured database for us to indicate that a person does maybe 1 or 2 hobbies only in an efficient manner. When we make use of data like JSON data, then we no longer have that issue because we would simply list the hobbies, and if hobbies are missing, we just simply leave it out. We're good to go. So that, in a nutshell, is kind of the it's a database systems. And I'm saying that we want to look at both of them so that you're a bit more versed as you traverse the space. Now, I also did say that traditionally, I would have download and install on your machines. But I'm saying increasingly, you will find that persons are talking more and more about there are several benefits of using containers. So what I think I want is try and make containers in terms of these databases, and then we interact with the containers. Still chipping out, but I don't know what to do then. Because I'm now on the wired. I'm now on the wired thing. Let me try it without this earphone. All right, disconnect and reconnect. Um, how we sounding now? All right. So, so I can continue from containers then. All right, cool. So traditionally, we would have said, find the installation files, install these databases on your machine, and then you spin them up and we interact with them using some sort of graphical user interface or command line interface. I'm saying though that as you look around within the industry, you'll find that persons are more and more talking about containerized solutions. And they're talking about containerized solutions because it offers several benefits, which which make it easier to deploy the kind of solutions that you develop. And the reason for this is pretty simple. And I just talk about a virtual environment that you're used to in terms of Python. Whenever we create a virtual environment in Python, what we're really doing is creating an isolated section whereby we can put all the packages which are necessary for the application to run smoothly in a common location. And because all of these are within the common location, then what it means is that we kind of get away from the ill effects of having incompatibilities between different packages and so on. In a similar manner, when we containerize a solution, what we're actually saying is that we are creating this container and we are putting all the necessary packages, dependencies, which are necessary within the container so that when we run the application has everything that it needs so that it can run smoothly. So when it's time to deploy, we simply move the container from one place to another spot and things will run smoothly because all the dependencies would have been taken care of and packaged together within the container. So I hope that analogy is good enough. If you want another analogy, think about, you fix cars, for example, and you have your specialized tools that you use to fix the car, whether it be a wrench or a jack or whatever it might be. It's specialized for vehicles. So what you do whenever you want to work on a vehicle is you pack up all of these and you carry them with you. And by virtue of you moving with these tools to different locations, you are now able to perform any task you want to perform on the vehicle because you know that you have the tool set which which you are familiar with and which you know can do the job. So you package them together and you carry them to where they are going to be used. It's a similar concept. We put all of the libraries together, which are going to work nicely together, and then we move the entire solution from platform to platform. And we should still have the same kind of experience because everything that is needed is working together. All right, so I think, yeah, that's pretty much what we do enjoy. But it's still going to be on your system though. It's just that it's going to be in a container on your system. And because it's in a container, it's like it's centralized. It's easy to find. When you don't need the container anymore, you can get rid of the container. So there are a couple of things that I'm going to be asking you to do for me. You don't have to do it now, no, per se, because it might take a little time. But the first thing I'm going to want you to do is to install something called Docker Desktop. Let me. So if you look here on my machine, you're seeing the icon. So that's the first thing I want you to locate because you're going to install that. It's called Docker Desktop. And the good thing with Docker Desktop is that it's a software that allows you to create these containers. So it will handle the task of creating the containers for you and facilitating the necessary communication and anything else that needs to happen when you're spinning up these containers. So that's the first thing. So I have opened up Docker desktop on my machine, and I just killed the container that was there. So there was a container that was running. I just killed it. And I'm going to launch a container. So I should show you what I did in terms of the code base. But notice here that it tells me that the container has started. And the name of the container in this case is Fast API Postgres 1. So I have just started the container. And I've used the command above to start the container. Docker compose, I want to launch the container, so we use the up command. And if you look back inside Docker desktop, realize that we have a container that has been spun up, it's running. That is the folder that I was working in. That's in Visual Studio. And this is the actual name of the container. So we'll put both things together and get the complete name. The port that it's running on is 5432. That's by default. And because it's a container, it means it's kind of isolated. So we have to find a way in which we can communicate with it from the outside world. So what we do is we map the internal port to the external port so that we can facilitate the communication. So that's why you see two port numbers here and the colon. One represents the inside port and one represents the port that we want to use on the outside. And typically, we just allow them to be the same value so that we don't have any headache. So that's pretty much what we want to get done. Now let us look at how we get it done. So remember, you're building APIs and you're building APIs using Fast API, which is a Python-based framework. So two things that you want to bear in mind. First thing, you want to ensure that you are inside Python, inside VS Code. And secondly, you want to ensure that you create a file called Docker Compose. And it's going to be a YAML file. So right here. You're creating that file. So it's docker-compose.yaml. And then we're going to talk about what you put inside of it. You're following so far, folks? Type Y if you are. All right, somewhat that means you're not sure. All right, so let's continue to talk. And then we can always backtrack. So what we are doing inside of this file is we want to run something inside the Docker desktop framework. In other words, we want to containerize something. I'll give you an example. Let's say that you have your machine here, it's Windows based, and you want it to run Linux. Then one of the things that you would think about is you create a virtual machine and you run Linux. Well, that's one way of doing it, and that works very fine. But another way in which you could do it is you could spin up a container that has a Linux. So you spin up a Linux container, and then you work inside of Linux within that container. It's similar to a virtual machine, but the fact is that a container uses less resource than a virtual machine does. So I hope that helps in terms of understanding what it is we're trying to do. And you can give me some feedback so I can know. All right, so let's look at the different parts of the stuff now that we actually do it. So there's going to be a services tab. And this is going to tell us all of the services that we want to spin up. In other words, all the containers that we want to spin up. And we want to spin it up in Docker. That's why we're using the file called Docker Compose. Because once we create this file and we use the particular syntax that we're talking about now, then it means that you'll be running your containers within the Docker framework. So we start out by defining the services that we want to execute. And notice right under that, you see it talks about running the service. So there's a little button there that you can click on to start the service. So now we're going to define the service. So the service is a Postgres service. So that's what we're creating. We're creating a Postgres service. And there's going to be something known as an image that we need to locate. So an image is a package that you're going to execute. And this package is similar to your installation package, for want of a better word. So for example, I could run a Ubuntu package. And what that will do is it will create a container in which Ubuntu is running. So I can be working on Ubuntu or using Ubuntu commands within the container. So what this is saying is that I want to get a Postgres image. And so there are going to be images out there which are already defined that you can make use of. So that's what this is saying. The other thing that is going to be important is that we need to configure the environment. And what this allows us to do is to set the parameters that will allow us to log into our database. And the ones which are important for us are going to be Postgres user, Postgres password, and the database. And what I have done here, just to make it simple, is for the user, I am setting the user ID as being Postgres. I'm also being very, very lazy or very smart, and I'm setting the password as Postgres so that we don't forget it. And for the database, the initial database, I'm setting that as Postgres DB. So nothing fancy, because I want to be able to remember these things when I'm logging in. The final thing here is that we are going to specify the port. And remember, I spoken earlier about mapping the internal port to the external port. And this is where we're doing it. So by default, the port that Postgres runs on is 5432. And so we are saying internally in the container, we still want it to work on 5432. And externally to the container, so that others can connect to the container from outside, we also want it to be running on 5432. So that's pretty much what we're saying. Now let me go back to Docker desktop. I'm going to kill the container. And I'm showing you here that if we use the run service button, then the container is going to spin up back once everything is configured properly. So notice it tells you Docker compose, and it uses the up with a -d. And if we go back now, you can see that we have spun up back the container. Now you want to ensure that the container is up and running before you try and interact with the container. Now this command that you're looking at here, docker exec, -it, allows us to log into the container so that we can start, interacting with the container, use our database commands and stuff like that. So we need the container name. So let's copy that command. Now, whatever you see in the angle bracket, it means that you now need to use that to replace that with the name of your container. So I had indicated that the name of the container, me, if I view details, and that's your container name. So fast API Postgres 1. Oops, did I close my desktop? Let me see if that is still running. All right, it looks like it's still running, so should be good. Look like I killed it after all. All righty. At least two arguments. Let me do view. So that's Postgres. That's the user. That's the database. All right, let me see that. Oh, yeah. So I had left off some of the parameters that were necessary. So I'm logging into the database. So I target the container, but I also need to specify the username and the database that I want to connect. And we are now inside the database. So once we see that prompt, it means that we are inside the database. So let's try to create a table called, let's say, student that has F name. Let's say varchar 20. And let's say, what's that going to be? Gender, varchar 5. Then let's insert into student and then values. Let's say Sue, and Sue is a female. We'll just put F. I not even know if I did put enough fields there, enough spaces there. And then let's select star from student. Why am I not seeing anything? That's a standard SQL command. Have I done anything wrong there? No, everything seems fine. All right. Just give me a second. All right, so I'm going to need to have a look back at why this is not giving me my data. But I think you kind of get the general idea of what it is we said that we're doing. So we're creating containers and we're spinning up the containers. We're interacting with the containers. And by doing this, we shouldn't have to be installing these things directly onto our machine. As you could see when we had a look at the desktop, I'm just waiting for it to launch again. All right, so it seems that it's something went haywire with this system because I'm not even seeing my desktop. Look like I closed it inadvertently and now it's not launching again. All right, so here's what I'm going to do. I'm going to kill PowerShell. I'm going to ensure that I close the container from inside the terminal. All right, so it looked like something hung for true. Yep. All right. And let me now see if I'm able to get back the desktop up. But I'm still not able to debug this now. It's going to give me more idea. So All right, so I'm definitely going to have to come back to you with this one, folks. So I'm just going to wrap up now. I won't waste the time. So the next thing that we are going to do is once we get this service sorted out properly, then we are going to create another service here that will correspond to MongoDB. And so anytime we want to spin up a service, we can come here and we can run a container for Postgres, or we can run a container for MongoDB, or we can make use of the option up here that says run all services, and that will actually launch two containers, one of them being for Postgres and the other one being for MongoDB. So once I sort this out, then I will come back to you. Well, I'll just do a recording and send so that you can see how to finalize and work with both of the platforms. And then once you have that part, then you know that you'll now be working with your APIs whereby you will be connecting to the databases and you will be doing the same CRUD operations, but you'll be targeting your databases instead. All right. So select from student. Don't tell me that. I hope, I hope that is not. All right, so let me do let me start back from scratch. So you are saying that I need to use cap locks for those things. That's what they're saying. Yeah. And don't leave it. Maybe say if this is the issue. So it's a F name varchar 20 and gender 20 semicolon.
So this is line because so we'll be assuming that you have not finished entering your query. This can lead to all kind of confusion. For example, if you enter the same query, you will have most likely create a syntax. But the student will say
Show me the create command. Yeah, so Joel is here helping me here. Him giving me some syntax. And then we'll just wrap up. Which leads us to an interesting point. Even though, so SQL is standard, so you use it to interrogate the major databases. However, it is about, let's say, 98% standard. You may find that there are some slight nuances with different database systems, and so you have to move accordingly. So there are some where you don't have to put the semicolon, it infers it for you, and you're good. So things like that. There are some which are case sensitive. So just bear that in mind.
so just run create database.
Now we have the database already table.
The table. So you want to create a table.
Yeah. So create your table name column here. With that.
Any with this one.
Create table. name varchar 20, comma, gender, it's a 10,
and then it was a
semicolon.
and then press save.
Oh, my bad. I saw what I did there. Gender must be varchar 10. Let me do a select first. Should get a null table. All right, yeah, so we get that. And now let's do the insert. So it seems as if the big letters matter. You can try it on your own. Insert into, and the semicolon definitely matters, all right? Values, and then we had said what, Sue, and Sue is a female. I think I made enough space, so I can now type out female and semicolon. Is that,
Well, this one specifies the rows.
yeah, if we're putting it in the same order, we don't need to put the columns. So I'm putting in F name, then I'm putting in gender. So standard SQL says once you do it in order, you don't need to specify the fields anymore. It will know it. So let's try that. Do does not exist.
Oh, so
Maybe
it
it
thinks
will
it's a
single quote.
column. It actually is thinking that it's a column for some reason. I don't know. Wait,
It could be single quotes.
let me see if it goes to.
All
Okay, there you
right.
go. Yeah, no.
So single quotes for string when you're using Postgres. And now let's do the selecting. So select star from student, right? Semicolon.
Okay, there we go.
All right, so there we go. So thanks to Joel, him help us to debug. And that is why using your user manuals is so important, folks. Because that is exactly what I would have done. When I finish and don't waste any time, then I would have go back, pull up the documentation and have a look. Yeah, so Joel was kind enough to assist on the fly, which is why we like having everybody here together at one time.
Yeah, it's a lot.
Yeah. All right. So I want you folks to install the Docker desktop and just take a screenshot of this, please, so that you know how to start the service. And then you just interact with the database on your end just to make sure that it's working. And then next session we look at the whole MongoDB and just tie up back everything, and then you start working on your um on your API. So we're going to end now for real, real, real. But before we end, ladies and gentlemen, read the gaming thing. Yes, the gaming something, the 2D game. I am depending on you to sort it out by the end of this week so that we have something to display for our opening. We cannot have an opening and we're not displaying anything for them folks. All right. So can I get some confirmation that you're going to go and work on it so it's finished by the end of this week? Come type in the chat, man, so we can see. All right, good. Excellent. We need that. All right, so that's us now, folks. And see you in our next session. Take care. No, man, it's a simple version we want, man. It's a simple version we want. We don't want the complex version. Yeah, man, cool.